Okay, so far we have discussed definition of boiler, classification of boiler, and we have seen one of the three boilers. That is, we have seen the Babcock and Wilcox boiler, a horizontal axis boiler. This one, this we have discussed. Okay, so in today's lecture we will be discussing one more boiler. So today we are going to discuss Cochran boiler. So I hope you remember what is boiler. Boiler is basically a device which is or a closed vessel which is used to generate steam. So this picture is a model of Cochran boiler available in our lab, and this is the diagram of this boiler. So from this figure only you can write the characteristics of a Cochran boiler. You can see the shell of the boiler is in vertical position. You can see this drum of boiler is in vertical position. So you can say it is a vertical axis boiler. And from this schematic, you can see there are more than one number of tubes. Okay, so you can say it is a multi-tube boiler. And from this diagram only, you can see the water is outside, and inside the tubes you can see what is coming. These flue gases are going inside these tubes. So this arrangement where inside the tube flue gases are available and tubes are surrounded by water, then that kind of boiler we can call it a fire tube boiler. And here we are firing the fuel inside the boiler shell. ये जो सिल्वर कलर का शेल है उसके अंदर हम फ्यूल बर्न कर रहे हैं. So that is why it is called internally fired boiler, and this also is a natural circulation boiler. Okay. So you should be able to write down these characteristics from this figure only. Okay, अगर आप फिगर पे से ये सब लिख सकते हैं, then it will be easy for you to write in exam. Okay, because it is possible that in exam they may ask indirectly that explain the construction and working of a vertical axis boiler. Okay, so at that time you should remember that Cochran boiler is a vertical axis boiler. So indirectly you are asked about writing the working of Cochran boiler. And these are some of the specifications of boiler. Okay, these are not important exam point of view. These are just for your knowledge. Typical, commonly the shell diameter, this diameter of this shell is 2.75 meter. Height is this much. Okay. These are the data for your reference only. So let's have a look at the construction. And before going to construction, first have a look at the components used in this boiler. So below over here you can see an ash pit is there, and on the ash pit or above the ash pit grate is there. Okay, now you should remember what is grate. Grate is basically a platform on which we are placing our fuel for burning. जब मैंने कंपोनेंट्स डिस्कस किए थे बॉयलर के तब मैंने डिटेल में ये सारे समझाए हैं. And on grate you can see here fuel is placed, and here a firebox or furnace, you can see this igloo type shape, a hemispherical shape. This component is firebox or furnace, you can see. And on right side over here you can see one opening is provided, that is fire door. Now fire door is basically an opening through which we are supplying fuel on grate. अगर आप इस मॉडल में देखोगे तो यहाँ पे ये जो कटआउट है दैट इज फायर डोर, यहाँ से हम अंदर फ्यूल जो है वो सप्लाई कर सकते हैं. Then this firebox is connected to combustion chamber. Okay, this chamber over here is a combustion chamber. And these two, furnace and combustion chamber, are connected with the help of this flue pipe. And on the bottom of this shell, you can see in water region, a blow of coke is attached. Okay. This coke or this valve is used to empty the boiler or to remove the mud from the boiler shell. Now this combustion chamber is connected to smoke box. लेफ्ट साइड पे जो ये स्पेस है दैट इज कंबशन चैम्बर और राइट साइड पे जो ये स्पेस है दैट इज स्मोक बॉक्स. यू कैन सी दिस box is actually smoke box. This combustion chamber and smoke box are connected with the help of these fire tubes. ये जो ट्यूब्स है वो पास हो रही है. कैन सी ओवर हियर, ये जो होल आपको दिख रहा है दैट इज बेसिकली ट्यूब्स. ये जो ट्यूब्स है उनका ओपनिंग दिख रहा है यहाँ पे. एंड स्मोक बॉक्स इज कनेक्टेड विथ चिमनी. Then water level indicator is attached to the boiler shell. Okay, water level indicator will indicate the level of water inside the boiler. Then feed check valve is provided on the shell to supply the water inside the boiler. Then manhole is provided over here to carry out the maintenance work. Then pressure gauge is attached on the shell. It will indicate the pressure inside the boiler shell. Then steam stop valve is attached on the topmost portion. The steam stop valve will be used to take out the steam from the boiler. कि जब हमको बॉयलर में से स्टीम निकालनी होगी तब हम ये स्टीम स्टॉप वाल्व है वो ओपन कर सकते हैं. Then for safety purpose, one safety valve is provided. Okay, don't bother about the name of this safety valve. There are 4 types of safety valve generally used. We will learn all of them in later on. Right now, just keep it as a safety valve. To avoid bursting or to avoid overpressure inside the boiler shell, a safety valve is attached on the shell. And this steam stop valve is joined with anti-priming pipe. Okay, now anti-priming pipe is basically a pipe, okay, which separates the moisture content from this steam. यहाँ पे जो भी steam generate हो रही होगी वो wet steam होगी. So to separate the moisture content and dry particles, anti-priming pipe is used. Okay, so it will supply only dry particles out of the boiler. Okay, so these are the components and their arrangement, or you can say construction of Cochran boiler. One thing to note over here is the shape of this furnace or firebox is hemispherical shape. Now hemispherical shape has many advantages. Okay, it is stronger. A hemispherical shape is stronger as compared to circular or spherical shape or cylindrical shape. Okay. And this hemispherical shape also enhances the radiation heat transfer. Okay, यहाँ पे सरफेस जो है वो ज्यादा मिलेगा. तो ज्यादा सरफेस मिलेगा मीन्स ज्यादा सरफेस गर्म हो सकता है. मीन्स वो ज्यादा सरफेस गर्म होगा मीन्स हीट ट्रांसफर के लिए सरफेस ज्यादा अवेलेबल होगा. The hemispherical shape of furnace can withstand high heat and is also useful to increase radiant heat transfer from the furnace to hemispherical furnace wall. So this is the construction. Now let's have a look at the working, how this boiler will work or how the steam will be generated. So suppose assume that we have purchased a new boiler. This is empty boiler. I have installed the boiler and now I am starting the boiler. Okay, assume that I have purchased new boiler. So first of all, what I will do? First, I will open this feed check valve और बॉयलर के अंदर मैं पानी भर दूंगा. नाउ कीप वन थिंग इन माइंड, आपको बॉयलर जो है वो पूरे का पूरा नहीं भर देना है. के अंदर कुछ लेवल तक ही भरना है बॉयलर, तभी आप ऊपर स्टीम के लिए जगह बचेगी, बिकॉज स्टीम जो होगी वो प्रेशराइज हो जाएगी. So with the help of water level indicator, you can set the level of water inside the boiler. अंदर कितना पानी भरना है वो आप इस वाटर लेवल इंडिकेटर से देख सकते हो. तो फर्स्ट आई फिल द बॉयलर विथ वाटर. सो मैंने पानी का इंतजाम कर दिया है. अब पानी में से स्टीम बनानी है, तो व्हाट इज अनदर रिक्वायरमेंट? हीट. तो हीट जनरेट करने के लिए फर्स्ट ये जो फायर डोर है उसके अंदर से मैं फ्यूल सप्लाई करूंगा. यहाँ ग्रेट पे, ग्रेट के ऊपर मैं फ्यूल रख दूंगा और उसके बाद फ्यूल को जला दूंगा. So as I burn the fuel, the flue gases will be generated. Flue gas जो होता है वो जनरेट होंगे. Okay. And that flue gases will be generated over here. And these flue gases will flow to the combustion chamber through this flue pipe. इस फ्लू पाइप की मदद से ये जो फ्लू गैसेस है वो कंबशन चैम्बर के अंदर आ जाएंगे. You can see the combustion chamber is closed from top. Okay, so फ्लू गैसेस कहाँ पे जाएंगे? ये जो ट्यूब्स है उसके अंदर चले जाएंगे. So flue gases will be passing from these fire tubes. Okay, ट्यूब के अंदर होंगे. So while flowing from these tubes, it will pass on the heat. वो जो हीट होगी, फ्लू गैसेस जो गर्म होंगे वो हीट वो वाटर को सप्लाई करेंगे. So water will get heated up, and after some time the water will be converted into steam. And we all know that density of steam is lower as compared to water. Okay, so steam will be flowing on top. You can say steam will be floating on top of the boiler shell. And after passing the heat to the water, these flue gases will go into smoke box. Just a minute. Okay. After passing the heat to the water, the flue gases will be flowing to the smoke box. Okay, they will come out in the smoke box. Now in smoke box, okay, the filtration process will be done, because what will happen, these flue gases may be possible that they may contain some harmful particles. Okay, and we cannot directly dispose these flue gases into atmosphere. Okay, so in smoke box, some harmful particles will be removed from the flue gases, and the remaining flue gases will be thrown out of the chimney into atmosphere. तो इस तरह से बॉयलर के अंदर स्टीम जनरेट होगी. यहाँ पे फ्लू गैसेस जनरेट होंगे, एंड वो फ्लू गैसेस इन ट्यूब्स में से पास होंगे. And heat transfer will be, major heat transfer will be happening over here. These flue gases will be transferring their heat to the water, and water will be converted into steam. Now what is happening? We have generated the steam, but what amount of steam is generated, that we don't know right now. Okay. So to get the idea about what the pressure is inside, okay, there are some mountings and accessories are attached to the boiler. So to know the pressure inside the boiler, pressure gauge is attached. And one more thing, the steam collected over here, कि यहाँ पे जो भी steam collect हुई है वो कैसे होगी? Wet steam होगी. Wet steam means this steam will having two particles, moisture particles and dry particles. Okay, so this anti-priming pipe will remove the moisture content. Okay, moisture जो होगा वो remove करके वापस से यहाँ पे नीचे डाल देगा और dry particles जो होंगे वो ऊपर जाने देगा. So the dry steam will be coming out of this steam stop valve. And in case the pressure over here exceeds the design pressure, suppose मैंने ये boiler डिजाइन किया था 5 बार प्रेशर के लिए, सॉरी नॉट 5 बार 10 बार प्रेशर के लिए, सपोज मैंने डिजाइन किया था और अंडर का प्रेशर 11 बार हो गया है, या प्रेशर गेज पे मैं देखता हूँ तो मुझे यहाँ पे 11 बार इंडिकेट कर रहा है, तो क्या होगा? वो डिजाइन प्रेशर से ज्यादा प्रेशर हो जाएगा. So for safety of the boiler, what we will do? We will eject some of the steam out of the boiler with the help of this dead weight safety valve. Safety valve क्या करेगा? थोड़ा ओपन हो जाएगा, तो steam जो होगी वो escape हो जाएगी यहाँ पे. The way it is happening in pressure cooker. तो क्या हमारे घर पे भी जब प्रेशर कुकर के अंदर का प्रेशर ज्यादा हो जाता है तो क्या होता है? उसके ऊपर का जो सीटी होता है वो लिफ्ट हो जाता है और स्टीम जो है वो आसपास से निकल जाता है. The same way it will be happening over here. अगर ज्यादा प्रेशर हो जाएगा अंदर, so some steam will escape through this safety valve. And suppose now I want to carry out the maintenance work of the boiler, तो क्या करना पड़ेगा? फर्स्ट मुझे जो पूरा बॉयलर है वो खाली करना पड़ेगा, मीन्स अंदर जितना भी पानी भरा है वो सब निकालना पड़ेगा. सो यहाँ बॉटम पार्ट में ये ब्लो ऑफ कोक दिया गया है, तो ये कोक मैं ओपन करूंगा तो इसके अंदर से पूरा मड वाटर सब निकल जाएगा, मीन्स बॉयलर है जो पूरा एम्प्टी हो जाएगा. Then a man can go inside through this manhole and carry out the maintenance work. And one more safety device is attached over here, that is fusible plug. That is also a safety device. Fusible plug. ये plug जो होगा वो क्या करता है? So first of all, let's go by its name, fusible plug. It can fuse. So this fusible plug, what will happen? अगर बॉयलर का टेम्परेचर डिजाइन टेम्परेचर से ज्यादा हो जाता है, मैंने जितना डिजाइन किया है कितना टेम्परेचर होना चाहिए मैक्सिमम, इससे ज्यादा नहीं होना चाहिए, अदरवाइज बॉयलर विल बर्स्ट. तो अगर टेम्परेचर ज्यादा हो जाता है तो क्या होगा? ये जो फ्यूजिबल प्लग है वो पूरा मेल्ट हो जाएगा, वो पूरा प्लग मेल्ट हो जाएगा. तो यहाँ कंबशन चैम्बर में क्या होगा? ओपनिंग क्रिएट हो जाएगी, एक होल बन जाएगा कंबशन चैम्बर के अंदर. यहाँ पे अगर अब यहाँ पे होल बन जाता है तो क्या होगा? ये जो पूरा वाटर है यहाँ बाहर, वो पूरा वाटर जो है वो कंबशन चैम्बर से होता हुआ यहाँ फर्नेस के अंदर आ जाएगा और ग्रेट के ऊपर जो हमारा फ्यूल बर्न हो रहा है उसके ऊपर पूरा पानी आ जाएगा. तो क्या होगा? वो जो फ्यूल बर्न हो रहा है वो स्टॉप हो जाएगा, तो टेम्परेचर विल स्टॉप राइजिंग. So that is how this is providing protection against overheating. तो ये जो fusible plug है, that is providing protection against overheating of the boiler. And down over here you can see air is going inside the furnace. Okay, I explained you in components portion that air is required for efficient combustion or complete combustion of fuel. Okay, so that is why the air is passing, and once the fuel is burned, the ash will be collected down in the ash pit. So this is how the Cochran boiler works or steam is generated in Cochran boiler. And these are the different mountings used in this boiler. Okay, you will have better idea of mounting once we start the chapter of mounting and accessories. Right now, you take it granted. Okay, this is the mountings: steam pressure gauge, water level indicator, deadweight safety valve, feed check valve, blow off coke, steam stop valve, manhole, mountings and accessories, fusible plug, and anti-priming pipe. These are the different mountings and accessories used in Cochran boiler. And I just explained you the use of each and every component, what they are doing. So now let's have a look at the advantages and disadvantages of this Cochran boiler. So first, it is compact and portable boiler. Therefore, minimum floor area is required. Also, its construction is vertical, so minimum floor area will be required, and it is portable and compact. Initial cost of boiler is less. Okay, one more thing. This Cochran boiler is also a low pressure boiler. Okay, अब लो प्रेशर बॉयलर है मीन्स प्रेशर जो है वो कम सस्टेन करना है, तो उसके जो भी कंपोनेंट्स लगेंगे उसका कॉस्ट भी लो होगा. It can be moved and set up readily in different locations. Okay, we can move this boiler from one place to another place. Okay, quick and easy installation. Any type of fuel can be used, that is coal or oil, any of these can be used. These are the advantages. And what are the disadvantages? The steam rising capacity is less due to vertical design. Water along with steam may enter the steam pipe under heavy load due to small steam space. अब क्या होता है, यहाँ पे जो स्टीम स्पेस अवेलेबल है वो काफी कम होगा. तो अगर अंदर का प्रेशर बढ़ जाता है या हम मैक्सिमम कैपेसिटी पे इस बॉयलर को रन करवाते हैं, तब क्या होगा, यहाँ पे एंटी प्राइमिंग पाइप जो है वो अपना काम ठीक से नहीं कर पाएगा. मीन्स सारा मॉइस्चर वो रिमूव नहीं कर पाएगा. सो सम मॉइस्चर मे एस्केप द बॉयलर थ्रू दिस स्टीम स्टॉप वाल्व. That is the second point. Water or moisture along with steam may enter the steam pipe under heavy load due to small steam space. And third one, efficiency is poor in smaller size. अगर हम इससे भी छोटा साइज करते हैं तो efficiency है वो काफी कम आएगी. So this is the construction and working of Cochran boiler. Figure is one more time is very much important exam point of view also, as well as your understanding point of view. So I suggest you do the practice of drawing this boiler also.